Alrighty then, corn children, children of the corn. It is a fine day for mathematics, so let's take a look at this. We're going to be talking today about limits where we can actually use direct substitution. Now before we talk about this, let's remember, there are times, here's our function f, it's a little curvy thing, there's a hole, there's the dot. There are times when the limit, which would be this height, and the function value, which would be this height, are not the same. In this picture right here, the limit as x approaches c does not equal the value of the function, the dot height. Yeah? The limit height is approaching here, but the dot height is there. And in this picture, with this example, these are not the same value. And what we're going to see in the future is we have to do other techniques. We might need to use a table, we might need to use a graph, we might need to use algebraic techniques, which are coming in a future lesson, where we can actually find this without plug and chug. But, there are glorious times, wonderful times, when these are equal. In the case of what we call a well-behaved function, a function continuous at C. Meaning, if we look at the picture, the dot height and the limit height are the same. If we trace without picking up our pencil, you remember that's the intuitive concept of continuity, and we don't need to do anything fancy here, then if we call this f again, the limit value is equal to the function value. The dot height and the limit height are the same height. So here's what's great. If, now that's a huge if our function is a well-behaved continuous function and we are asked to evaluate a limit, we should attempt to just plug C in. If nothing strange happens, meaning division by 0 or weird behavior, that's the answer. What? Yeah, I know. This is going to be so delightful. Are you ready? Are you ready? Consider with me the following limit. What is the limit as x approaches 4 for the function? Now here's where our function goes, and the function is 6. What? Yeah, 6. Like y equals 6. F of x equals 6. Well, what does the function y equals 6 look like? Isn't that just a horizontal line at a height of 6? Why, yes, it is. All of those dots are lining up at a height of 6. And the question is, what is the limit as x approaches 4? 6, 6, 6, 6, 6, 6, 6, 6, 6. 6, 6, 6, 6, 6, 6, 6. It's like the devil. 6, 6, 6. All of these are approaching the dot that is at 4, 6. The dot height and the limit height are the same. The answer is 6. Okay. It's so obvious, it's almost confusing. Let's try another one. Come on, it'll be fun. Let's look at the limit as x approaches 2 of the function 4x squared plus 3. 4x squared plus 3, isn't that just a parabola that's a little bit skinny and then moved up 3? Yes, it is. So if we have a parabola that's a little skinny and it's moved up 3, there's 3, and we're looking at the value, or the limit value at 2, isn't the limit answer going to be the same as the height of the dot of the parabola? Yes, here's what I'm telling you. Here's what I'm saying. Plug 2 in. What? There's no division by 0. There's no denominator. There's no weirdness. This is a lovely continuous parabola. You can trace it from left to right without picking up your pencil. To get the answer to this limit, all you have to do is fill the 2 in. Direct substitution. I know. So we math. Wait, 4 times 4, 16, plus 3, 19, I'm pretty sure. And that is this dot, 219. It's also the two sides are approaching a height of 19. It is that straightforward. That's why I'm putting this in the video lesson, because it's obvious. Well, okay, maybe not obvious, but it's pretty darned obvious. Consider the following. You ready? Okay, how about this one? What is the limit as x approaches 3 pi over 4 cosine x? Okay, so the function is your cosine wave. Well, that's a lovely continuous function. You remember the waves, it just goes. Okay, I'll draw a picture. Remember this? There's the function. I know, right? It's continuous. There's no holes or breaks or asymptotes or anything. It's a lovely continuous function. And the question is, well, what do? We evaluate. We direct substitute. Oh, so the answer to this will be the cosine of 3 pi over 4. What's the cosine of 3 pi over 4? You have to remember. I know. Instead of looking at the wave function, which you can, I'm going to consider, I'll put it right here, the unit circle. Do you remember our unit circle? Once around the circle, 2 whole pi. So this would be 1 pi. That would be half of a pi, so 3/4 of a pi puts us over here. Cosine is, can you hear it in your head? Cosine goes with x. It's going to be the x-coordinate. The y-coordinate could be found by using sine. I'm not going to talk about that because it's not in the problem. How do we remember the value? We look at our left hand. We say this is pi over 6, this is pi over 4. We bend our finger under. There are 2 fingers here. This is the x, comma, y. 2 fingers represents radical. There's the 2 over 2. Those are your 2 fingers right there. But in this quadrant, the x's are on the left, so the answer is negative. That is a little pre-calc reminder of how to evaluate a trig function. But the direct substitution is how we answer the limit. Campers, if you can use direct substitution and you don't get any weirdness, you don't get any division by 0, do it.